Here it goes. You're on.
Good, ready? Okay, hi, my name is Patrick Schlott. I'm a sophomore in the Electrical Engineering Technology program at VTC, and this is my project. It is a DMX 512 data splitter. Alright, so before I go into DMX and what my project is about, I'm going to do a brief history of stage lighting. So I'm very personally interested in stage lighting technology. I have a background in working in the field for about 6 years now. And conventional lights in theaters are just big incandescent lamps. You got a quartz lamp that's about anywhere from 500 to 1,000 watts. And they were operated using giant resistors, essentially. And you can imagine this is a really inefficient way to do lighting. There's a lot of waste heat, and there had to be ghost loading. So, if the lights you plug into one dimmer doesn't match the wattage rating for that dimmer, you had to plug lights into it until it was fully loaded. So, at best efficiency, I think it's for resistors something like 50%, 25%. And, they were large, inefficient, and, you need a lot of hands to run. So somewhere in the 1950s, I think it was a Superior Electric company, they already had the Variac, and they made the auto transformer dimmer board, which, in lab we use the Variacs or auto transformers. So they're a lot more efficient, but they're still very big and heavy. And fun fact right here, this picture is guys from my old high school using the dimmer system. I think that picture was taken around 1971. So that's a real life example of what an auto transformer dimmer board looks like. So go on to about 1970s, and then a company called Strand starts inventing electronic control. It's analog. So a lot of the old lighting systems were 0 to 10 volt. But again, if you have 96 channels of dimmers, and by a channel I mean you have like a fader on your control board, and then that goes to like one dimmer and then one light or a group of lights. So if you have 96, you've got to have a common wire, and then you have 96 individual wires going through a giant cable to control 0 to 10 volts to ground for each dimmer module. And they're susceptible to noise because it's all DC. It's not more efficient today. Like we have PWM, then you have a filter circuit at the other end. So then you come up to 1985, and USITT, which is the United States Standard for United States Institute for Theater Technology, developed DMX 512, which is a digital lighting control protocol. DMX stands for Digital Multiplex. They kind of screwed that up there, with 512 pieces of information. It's an 8-bit protocol, and you get 512 channels for one DMX universe. This one. And this, I was talking earlier about resistance dimmers. This is what they look like. They're gigantic. They have wired wound plates, and they get very hot, and everything's exposed, and they're not very safe. And unfortunately, I had the pleasure of working with one at one point, so there's that. And so for a background, DMX 512, not the wrapper, is a digital control protocol. So essentially what DMX does is allows something like a controller to talk to dimmers, LEDs, scanners, moving heads, all your fancy smart lights you have in theater today. And it's based on, if you're familiar with RS-232, is a serial protocol for computers. This is RS-485, which is another serial communication standard. And it runs at 250 kbaud, which by today's Ethernet standards for internet is slow. But DMX is very robust. It works very well. It's the industry standard for today. And the connections, if you're into audio, the XLR connector is 3 pins for like a microphone. This uses 5 pins. And move on. All right, so how it works, you have a differential signal. We talked about differential amplifiers in electronics. So I took a shot of this old analog scope here. You have the data minus, which is your pulses going down at, I think it's 4 microseconds for 250 kbaud. The refresh rate, which I'll get into later, is 44 microseconds. And then there's your data plus. So I had to go from ground to data minus and then do it again for data plus because I only had one scope. And yeah, so you have 2 lines, differential signaling, and the voltage levels for RS-485, the receivers need at least 200 millivolts in the plus and minus directions to run, and the maximums are they're not equal, so you don't have like plus 12, minus 12, it's plus 12 and minus 7, but I was unable to, I searched for hours, and I was unable to figure out a standard voltage for any given DMX to like a console outputs, 0 to 5 volts and then 0 to minus 5. And those are the signal components there. But I think the receiver, the way I understand it, The receivers will tolerate between 200 millivolts, so they actually turn on, and then +7 and -12, that's a threshold. Right. For the network, if you're wiring up dimmers and consoles and smart lights, you have a twisted pair cable for noise immunity. So you have a shield around it, so you have like foil, and then you have a wire to connect for ground. And the reason it's twisted is so it can provide 120 ohms of characteristic impedance. That's basically your cable's capacitance. And terminators for RS-45 and DMX networks are 120 ohms. So basically, you have your last device in the chain. You take a plug with a 120 ohm resistor across the two pins. You plug it in so that you don't get reflections. Your lights don't go all crazy. And basically, in theaters, people say, "Well, can I use a mic cable?" Well, consider this. We've learned about filters. Audio signals are limited to about 20 to 40 kilohertz. DMX signals are 250 kilohertz. So if you have something filtering above 30K, your signal is going to it's just going to be mush on the other end. So use the proper cable. All right, so for the actual data, this is how it works. So you have DMX, you have a start code, and then you have each channel. You see now all DMX levels are zero. I don't know how easy that is to see. You see channel 1, channel 2, channel 3, they're all off. So in these bits, you have this. It's 0 to 7, or it's just 8 bits. So depending on which ones are high, it tells you what level this channel is at, and that'll go to your light or your dimmers or whatever. And your devices are addressable. So basically, if you set your dimmer pack or your LED, I want this to come on at channel 5 through 8. You can turn up channel 1, and it'll go through the chain, and it'll say, I don't want to listen to that. The device will basically wait for channel 5 through 8, and it'll say, okay, those are the ones I want. And then it'll turn on accordingly depending on what channels you have. Now, it does this, it refreshes channels 1 through 512 44 times a second. So the refresh rate of all the bits you have to do for every single channel in the network basically means you have a very smooth fade for your light, so it's essentially dipless. Right, so for a theater, I've done it simple here, only did one fixture. You have your console, then you attach it with that twisted pair DMX cable to your dimmer, and then the conventional fixtures, just incandescent lamps, plug in with just regular power, wall socket power, into the back, and pretty sure dimmers of today are all SCRs, so it's all electronically controlled SCRs with that phase control we learned in industrial. So that's, conventional theater. Then you go on to that's an example of what you call a shoebox dimmer pack. It's very small, so instead of having, in a theater, you have your DMX line go to your dimmers and then all the power comes in, you distribute your DMX and then your lights plug into the pack so they're clamped to like a bar or something. Just figured to show that picture. All right, so for more advanced fixtures like LEDs, they actually just plug in their regular power and they're controlled, their intensity is controlled with DMX. So you run your cable out, and each fixture has an in and an out. So you plug in, and you link to the next, to the next, to the next. And for DMX RS-45 network, you are allowed 32 devices per universe. So even if you have 512 channels, if you don't use all of those, and you have if you have more than 32 lights, you can't do it. Not without a splitter, anyway. So this is where my project comes in. It's more of a sorry.
Back up a bit. Could you have multiple lights on the same address?
Yes, you can.
So you could have 132.
Well, I mean, you can't have it's a device thing, not an addressing problem.
Okay. So it's a loading problem.
Yes, it's like data loading. So so you have 3 lights over here, and then you have 2 all the way over here, and this is a very long distance. So instead of running your console to these 3, then running a long cable to chain these 2 together, which if you're not using the right cable, can introduce noise. It's a very long distance. You get a ground loop. You use a splitter, which takes the DMX, and you can't just wire them in parallel because you'll get reflections. I mean, if you could, then my project would be pointless and I wouldn't be here today. Ignoring that, you have, my box has 3 outputs. So the first one goes to these, and without this long cable, you just take one of the other outputs and run it to these 2 and chain them together. And here, inside of my circuit, is how the data flows. So you have your regular old, run-of-the-mill DMX 512 signal from your console coming into a 6N137 opto isolator. So basically what this does is you have an isolation barrier here. So it's 2,000 volts worth, so if your rig gets struck by lightning, you blow out a 50-cent chip instead of a $20,000 piece of equipment. So then, and you'll see this in my circuit diagram, is you get single-ended, what it looks like single-ended output out of the chip, but it's actually multiplexed. That's DMX, digital multiplex. And then you have this optically isolated signal, goes into differential bus transceiver chips, which basically take the muxed signal, demux it to the two lines and ground again, and these are your buffered, like, safe outputs, and you have three of them. So, here's a circuit diagram that is harder to see than I anticipated, so just bear with me here. So this top part you can ignore for now because that's just the power supply for the ICs. You have your data lines coming in here. There are two 68 ohm resistors and then a 2.2 k ohm LED, which basically says if it's flashing, the positive and negative directions of DMX tells you that you have a signal. Goes to the chip. There's an opto transistor inside of this. Then you have an enable line here to pull up resistor, and then your output line is also pulled high. So basically, you're sitting at 5 volts, and your DMX output is pulling it down for your mux. And then this goes all your transceiver chips, and then they have two lines tied together, and then they use diff amps to demux the signal, and then your output on the other side, and then all the grounds, DMX and power grounds, are tied together. And one thing, this will come up in the next slide, that is 68 ohms and 2.2 k ohms is, here's the interesting thing. I'm going to go next and then go back. For RS-45, this is what they call a bias and termination network. So if your devices or receivers aren't doing anything, this is so you don't have noise. So you have your 120 ohm termination, and you have 680 and 680 on either side. And the 68 and 68, that makes sense. Someone could have missed a zero. I could have written the schematic down incorrectly. The thing is, my circuit works with the 268 ohm resistors. Now, I had enough parts to rebuild the circuit. I had enough chips to build the whole thing twice. So I did it again with 680, 680, and 120, and it still worked somehow. So I've come to the conclusion that it's not a voltage divider to make sure your chip or LED doesn't burn out. It's just a bias to make sure you don't have any noise. So that's how that works. And then, of course, that would be here. So you have, resistor, 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 and then that's the rest of your circuit. Right. So, and then here's my printed circuit board design. I'll see pictures of that, and then after this presentation, I'll show you the box I made. Right, so why does the project matter? Why did I build this? So optosplitters are used for larger theaters, with lots of lights in various locations. I showed you that long distance cable example. And if you don't have a lot of long cables, linking would be a waste. And it's just more convenience factor and safety factor because now that you have a buffer, it's kind of like using an op amp as a buffer amp. You get a unity gain, and it has impedance isolation, so you're less susceptible to electrical interference. So as I said before, a lot of the fixtures, the daisy chain, is you have your controller, you go into a light, and then it's just in, out, and then all down the line. And the opto allows you to do star connection. So like I said, 32, we're limited to 32 devices per network, per universe. This allows for more. So you can have, you take your console into this box, and then you have 32 on here, here, and here. So that's a great advantage if you're using a lot of smart lights. And again, the opto coupler chip that I mentioned provides electrical isolation. It's like a isolation transformer. And it's also safe for, like I said, the lightning. If your rig gets struck by lightning, you're not going to hurt something. Right, so the thing is that opto splitters like this are already on the market. And you can buy something from China for around $100 and $200, but how long is it going to really last you? And some of these are not actually opto isolated. They just have the DMX signal go into the buffer chips, just so you can split. They don't even have the opto isolation, which is, you know, some people consider, you don't really need it. Depending on where you are, you know, it's more critical. And, you know, some of the more expensive ones, if you look at Doug Fleener design, and don't get me wrong, like his stuff is great, but it's $1,000 for a unit like that for the same number of outputs. And I mean they're pretty solid, but I just can't justify spending that kind of money for something I just built. And you know, a lot of the newer technology, you're going to have you know, integrated circuits and SMD. So you know, something blows, you got to send it to the manufacturer. If you don't have a good hand for SMD soldering, you know, very tiny components. You know, my splitter, if you can see here, this is a picture I took of the PCB. Very basic construction. Everything's socketed, so if you blow a chip, you can just pull it out and drop in a new one. You know, replaceable IC, very simple construction. And this box, I'd like to take this time to thank Kevin Worth for designing this 3D printed box in SolidWorks and having it, over there. So if you can't see, it says enclosure by Pat Schlott and Kevin Worth. So credit where credit is due, I suppose. And I bought these connectors, wired them on, and I don't have the nuts to hold the nuts and bolts to hold the top on. So I'm just going to undo this piece of tiling and show you guys the inside. You have to do some cable management, but that's what that is. So it's just your input. And this jack right here, if you can see, it's a 1/4-inch jack that's normally used for audio. The reason I didn't use a DC barrel jack is because this is almost locking. So it's, you know, if someone bumps it or moves around, and if you're in your lighting booth and doing a show, it's not going to come unplugged and then all your lights go out and then everyone starts looking around. So that's why I chose. Sorry?
Lighting is a contact sport.
Yeah. Not usually, but you know, when you have a messy sound guy and you're going to move things around, it happens. But so there's that, and here's the semi-custom power supply. I just had a 9-volt supply and I put a plug on it. So there's that. And yeah, so 3D printed enclosure. And Mr. Crea recommended putting a Schottky diode on the voltage input, so you know, if something gets wired backwards, it's not going to blow up. And Schottky, because it's only a 0.3 volt drop instead of 0.7, is a silicon. And there are LEDs on board, so if you need to troubleshoot, you can say whether the board is getting power, whether you're getting DMX. And like I said, there are 3 outputs. And this is a screenshot I took. If you do a simple Google search, this is more of a price point persuasion. And you see something pathway, you know, almost $800 for a splitter. And that does have a lot more outputs, but you could refine the board that I've made to have it do 8 or 16 or whatever. So there's that. And yeah, I'd like to open it up for questions at this time, if you guys have any.
I have a question.
Sure.
Do you have a sense of what the distance really is that you run into and you need to use the splitter? I mean, is it 100 feet? Is it 500 feet?
Yes, I do. I actually did research at one point. They recommend for cable runs between like over 1,000 to 3,000 feet that you use a buffer, which is basically, it doesn't have the opto chip. Instead of a splitter, it just takes all your DMX, buffers it, so it's like a stronger signal. It's kind of like a boost circuit for like a telephone or something, so you don't get like distortion. And they say if you're using like not great cable, the limits are about 500 to 700 feet. If you're using good cable, it's between 1,000 and 3,000. And beyond that, even with really good cable, you want to use a buffer. And you know, a splitter would come into that because it technically is a buffer. You know, if you're running one 3,000 foot DMX, and you want 3 outputs, put that in the line. So, to answer your question?
I think so.
All right. Anyone else?
So, you said that this project would cut down your use of cable.
Yeah, it depends on the situation in which you're using the thing, but
Right, is that because you're not running an individual cable for each light to send individual signals across?
that's right. So I'm going to use, when student events board, we do a dance. You know, we have that trussing.
Yeah.
So what I usually do is we have one of those long LED bars on the table as we're DJing, just as an effect. And I run my console to the opto splitter on the floor, which one of the outputs goes up to the truss, and then all the devices on the truss are linked together. And then instead of running another cable from the end down into the LED, I just use the splitter and connect another one. So it's right there.
Gotcha.
So yeah, it does cut down on running extra cable.
Right.
So in terms of the DMX protocol, all the signals go to all the devices.
Yes.
It's really the address on the device that determines if it's going to respond.
Exactly. It's packet-based information protocol, so.
All right.
Anyone else?
Yeah,
Anyone else?
Okay.